Next experiment to measure a output power and efficiency complementary symmetric amplifier. In the previous, you have already seen the push-pull amplifier. In the push-pull amplifier, there is a two transformer and there is a same type of transistor ANPN, RRPNP, means same form. You see the circuit diagram here. The transistor, one of the NPN and next one is the PNP transistor, and there is input apply from this one and output taken to this load. Observation table you see here. The observation table is similar like your push-pull amplifier. We move to your trainer kit. You see here, this is one as the circuit diagram of complementary symmetry push-pull amplifier. Input is applied in this two terminal and DC supply is apply this one 10 volt and this one is the ground and output taken from this one terminal. Okay, this trainer kit, this section is represent your complementary symmetry push-pull amplifier. Now we use a function generator or AC as a AC input. Now this AC input apply to your input terminal. You see here one of the positive terminal is connected this one and ground is connected to this terminal. And next one we connect your DC supply. Next this one your positive one of the ground. This one connected to your DC supply. DC supply is considered 10 volt. This one at 10 volt is applied here. This one your 10 volt. One of the ground terminal is this one connected. Now the output taken across these two terminal. Now we use a multimeter to measure your output. Here your multimeter. Now multimeter is connected. One of the positive terminal this one terminal and one of the ground terminal of this one. Means whatever AC signal you apply, the amplified output come across your this load. Means whatever output is come out, you see in the display of multimeter. Now we have already seen the table, observation table. By changing the load value, means load resistance value, we measure the efficiency. Whatever the resistance value changes and we consider the output in the particular load. There is a load resistance. You see here, there is resistance is indicated here in the circuit. By varying this knob, we change the resistance value. Now resistance value, if we want to see, use your multimeter rotator this resistance. Now connected this one. This display your resistance value. Overall, you this load resistance connected to this output terminal. By varying the load resistance, we see the output of the voltage and then we calculate your efficiency. Now this load resistance is now connected. Next to move your to measure a output voltage. Now to see here, we connect a negative terminal and this one and one of the positive terminal is this one. Okay, this is your connection of complementary symmetric push-pull amplifier to calculate the efficiency. Now how you calculate? We see here, first we find the input voltage. Input voltage means this is your DC supply is as a input voltage. Now we find a input current. Input current, how you find this supply? You connect a multimeter to series with your DC supply. Now we connect your multimeter as a series. Now this one was the positive terminal is connected to this one terminal of positive, and next your ground terminal is goes to your next of the positive terminal of complementary symmetry circuits. This ground terminal is moved to your next one is your positive terminal. You see here this one positive. Now this is now multimeter used as a series form to indicate the current flow. Means voltage multiply current. This one gives you power. Power as an input. VI. P is equal to VI. This is your input power. Now we calculate the output power. Output power is calculated using the relation V square by R. Means this one whatever the display is given you in the output voltage divide by R. R means what is your resistance is in this load terminal. Means V square means this voltage square upon R. This one gives your output voltage. Means input voltage voltage multiplied by current VI and output voltage V square by R. What is your resistance? Means now divide output upon input power, you gives the efficiency. Okay, this one calculation of your complementary symmetric push pull amplifier. You see here the table of the observation table. You see here the load resistance we consider 2 ohm. The source whatever input apply 8 voltage and the current is come 0.1. Means power is calculated 8 multiplied by 0.1. This one goes zero point 0.8. Now we find the output voltage. Output voltage now we calculate in the RMS. Means then next to your V square by R the relation we use here. Peak to peak, if there is peak to peak divide by 2, then we are divided by root 2. This one gives you RMS value. Means this one is with V square by R. Now we find the output power. Now efficiency output upon input. This one is calculated. Okay.